Hello everyone, welcome to the course on electrical circuit analysis. Today's topic is network graph theory. These are some of the terminologies we will be using in this slide. So in this slide, what we are going to see is the network topology. What is meant by the topology? Topology means the structure. This is the given network in which we can see that R, L and C elements are connected, and we have one voltage source as well as one current source. This we can convert to network graph. The first step is we have to remove the sources. The voltage source can be removed by short circuiting it, and the current source can be removed by open circuiting it. In this circuit, we can note that this is one node where three branches are connected, and this can be considered as a second node, and where again the three branches are considered, and this can be considered as again one more node. Here four branches are connected. One is this one, second one and third one, it is connected here, and fourth one it is a old current source. But in the network graph we are removing this because we have open circuiting this current source, so we will not have this branch. So only three branches will be available for this particular node. So we have named this node as 1, 2 and 3, 1, 2 and 3, and the fourth node is at the bottom. So here again the four branches are there, but this branch is considered as open circuited. So we are having three branches, one with C2, another one is L3, another one is this one. This voltage source is short circuited. Okay, so now we can form like 1, 2, 3, 4, 4 nodes are there, and the branches can be indicated by this line segment. Okay, this one branch represents that there are two elements R1 and C1. We are not representing the element as of now. Okay, we are just representing how it is connected. That branch is how it is connected. That is between which node to which node it is connected. That is the only thing we are going to note it here. This we will call it as a network topology, as I said earlier. Okay, network topology is nothing but a structure which tells you like which branch is connected to which node. This we will call it as a primitive. This network graph can be called as a primitive graph, primitive network, from which we are going to calculate the branch currents and nodal voltages, and whatever we have calculated in the module 1, similarly we are trying to calculate it but with a network topology. Okay, so tree can be connected in any way. One is shown here, another one it can be like this also. There is no closed loop, but it is connecting all the nodes, right? So this is another way of drawing the tree, right? Next one is the co-tree. It is nothing but the branches which is connecting all the nodes. Okay, but it will not include the branches of the tree. That we will call as a co-tree. Co-tree usually it will be a closed path. Okay, so these branches we will call it as a link, because connecting a link between these two makes the tree to a closed loop. Okay, so that we will call it as a link. Okay, so whatever the branches apart from this tree we will call it as a link, because it will form a closed path for this tree. Okay, so when we are combining these two, we are getting the original network graph. Okay, by splitting this way we are trying to analyze the circuit, given circuit. Okay, so in this slide we have seen this is a tree. Tree is nothing but node minus 1, n minus 1. N is represented by the number of nodes. Okay, and B represents the number of branches. Okay, so link is nothing but the branches. How many branches are here? 6 branches are there, and minus n tree. What is the tree? Tree is the number of branches in that particular tree. So 3. So there should be remaining 3 links are available here. So this forms T. Otherwise the tree plus link will be branches, right? In order to analyze the given circuit, we will be seeing about three matrices. One matrix is the fundamental incident matrix. This incident matrix can be written with nodes into branches. These are represented by the nodes and the columns are represented by the branches. The branches of the incident matrix are grouped in such a way that the branches of the trees, that is the twigs, are arranged as one group and the branches of the links are arranged in other loop. Here the branches 2, 3 and 4 are the twigs and 1, 5 and 6 are the links, so it is grouped into 2. Okay, and this incident matrix can be written like this. First, if you are considering node n1, we have to check what is the orientation of the branches. Here I am using the branch only because I am not using any current or voltage here. I am not including any current or voltage here, so I have to mention only as a branches only. Okay, when a branch is present at that particular node, then we will mention it as 1 or minus 1 based on its orientation with that particular node. Okay, when that branch is not associated with that particular node, then we will mention it as 0. By this way we can form a matrix. Here if you are considering node n1, that is first node, the branches 1, 2, 6 are connected and it is oriented away from 1. That is, it is showing that it is moving away from 1. Okay, so that branches 2, that is 1, 2, 6, right? 1, 2 and 6. Since it is moving away, the branches are oriented away from that particular node, we are mentioning it as 1. Okay, so in the second node n2, branches, what are the branches available here? It is 2, 3, 4. Okay, 2, 3, 4 branches are available at this particular node, and how they are oriented? This 2 and 4 are towards node 2, whereas the branch 3 is away, oriented away from 2. Okay, that's why this 2 and 4, branch number 2 and 4, it is having minus 1, whereas branch number 3, it is mentioned as plus 1, since it is moving away from that or oriented away from that particular node, second node. Okay, and similarly n3, the branches 4, 5 and 6, right? Branches 4, 5 and 6, only 6 is approaching that particular node 3, that's why we are having minus 1, and the branches 4 and 5 are moving away from the node, that's why we are mentioning as plus 1, whereas the other branches since it is not associated with 3, we are mentioning it as 0. Similarly we can write for n4. Okay, so here one thing we can note is when we are adding all these elements of this column, we will be getting 0, right? The elements of all these columns, individual columns, if you are adding up, then answer will be 0. That is one of the property of this incident matrix. Why we are getting it? Because one branch starting at one node, it will end at some other node. So once the starting of the node, we will be mentioning as 1. Once it is ending node, we will be mentioning as minus 1. So it indicates that no nodes are left over, or all the branches are connected between the two nodes. Okay, so you can verify like this, right? So and one more thing is the determinant of delta F is 0, because of this it becomes a singular matrix. Okay, in order to avoid this singularity, what we are doing is we are moving out one of the node. Okay, we are instead of 4 node, we will be considering only 3 node. Okay, but the same thing we have seen it in the nodal analysis also, right? The matrix what we are obtaining after removing that one node, reference node, that that we will call it as a reduced incident matrix. Okay, so instead of 4 node we will be having only 4 minus 1, that is 3 nodes only. So here I am removing this third node because I am considering this as reference. Okay, so so now the rank of the matrix will be n minus 1 because the singularity is removed because of removal of one of the nodes. Okay, that's why the rank of the matrix will be n minus 1. Okay, so I told you in the first slide that we can have any number of possible trees. I have told you in the beginning that the number of possible trees we can draw for a given nodes. Okay, so for to determine that how many number of trees can be drawn with the given nodes, that can be given, that can be found out with this formula, that is determinant of A. You have to take a matrix A. Next you have to multiply with the A transpose. A transpose means you will be changing the columns into rows and rows into columns. Okay, and then multiply both the matrix. After that take the determinant. That will give you the number of possible trees. Okay. Okay, and here this A matrix can be written like I have already told you, it is divided into two groups. One group is dealing with this matrix, and another group is dealing with the link. Okay, so this matrix A can be divided into two parts, AT and AL. AT belongs to the matrix, incident matrix of trix, whereas AL represents the incident matrix of the link. Next is the tie-set matrix. The tie-set matrix is designated by the letter B. Okay. It is similar to the mesh equations. Here the equation is formed by identifying the loops. Okay. So the first step, as said before, you have to identify a tree, and you have to identify the tricks as well as links, and assume directions. You have to assume some directions to the branches. Okay, these two things, these two things it has been told earlier also. Okay, here next thing is like you have to form a loop. Okay, you have to identify a loop, but one condition is that loop should contain only one link. Okay, that particular loop should contain only one link, and the direction of that particular loop will be similar to the direction of that particular loop link. So first, if we are considering this L1 loop, okay, L1 loop, what are the links present here? Only one link is present in this loop L1. Okay, only one link. Link is usually represented by the dashed lines, right? So the link, there is only one link in this loop, and the direction of this is like similar to that of L1, like a loop, link L1. Okay, and similarly we can have another loop L2. L2, it is again one L2, again it is having only one link 5. Okay, and the direction is associated similar to that of the link 5. Okay, and similarly L3 also, it is the direction of the loop L3 is similar to the direction of the link 6. The tie-set matrix is formed between the loops as well as branches, L into B. Okay, size of the matrix will be L into B. L represents the link or loops. Here it is both are same, right? We have formed the loops according to the links only. So number of links would be equal to number of loops. Okay, so if any branch is associated with that particular loop, then we will be considering 1 or minus 1. Whereas if it is not associated, then we will be considering it 0. Okay. Suppose if you are taking L1, in this L1, what are the branches associated with L1? It is 1, 2 and 3, right? 1, 2 and 3. Since the link is the direction of the link as well as the loop is same, we will be mentioning it as 1. So if you are considering this L1, what are the branches available with the L1? 1, 2 and 3. Okay, 1, 2 and 3. The direction of 1 is similar to the loop L1, whereas the direction of 2 and 3, it is opposite to that of L1. So the branch 2 and branch 3, it will have the -1, whereas branch 1 will be 1, others will be 0. Okay, and similarly loop 2, the branches associated with this loop 2 is 3, 4 and 5, right? 3, 4 and 5. The direction of this 5 is similar to L2, whereas the direction of 3 and 4 is opposite. So the direction, the B3 for the loop L2, B3 is -1. For loop L2, B4 is -1, and whereas B5 is +1 and others becomes 0. Okay, and similarly we can write for L3 also. This B matrix can be again divided into two parts. One is the branch, one is the Tizet matrix, which is related to Twix. Another is the Tizet matrix, which is related to the link. Okay. The link matrix, it is a unit matrix, right? The diagonal is 1, whereas the off diagonal is 0. So this is a unit matrix, so it is represented by U. Okay. And the third matrix we are going to study is the cut set matrix or node matrix. Okay, this is similar to our nodal matrix. Okay, here the first two steps are similar to the as before. Now the third step is like you have to identify a cut set. What do you mean by cut set? You are cutting a graph into two halves. Okay, that is known as cut set. Okay, but how the cut set should be? The cut set should have only one twig in it. Okay, the cut set you can draw. You have to make the graph into two, but how you can make it? Make is like you should have only one twig associated with that particular cut set. Okay, for example, if I am taking this C1, it is dividing the graph into two, right? The first node is separate, and if you are cutting all these, like cutting means you are just removing all the branches, which is cut by this cut set. Okay, so if you are using this cut set, that 1, 2, 6 can be removed. Once it is removed, the graph is divided into two parts. One is having one first node, and the other part of the graph will have this 2, 3 and 4. Okay, so the cut set means it is cutting the graph into two halves. Okay, and but the condition is the cut set should have only one twig associated with it, and the cut set direction is also similar to that of twig. Okay, here what is the twig is 2, the branch 2 is the twig. So the direction, it is, what is the direction of this 2? It is oriented away from that particular node 1. Okay, so whatever the cut set will also be oriented away from 1. Okay, so if you are taking the cut set C1, what are the branches it is associated with it? 1, 2 and 6. Okay, and what is the direction of the branches? It is similar to that of the cut set, which is oriented away from this. The branches 1, 2, 6 are associated with this cut set. Okay, and the direction is also similar to that of C1. So that's why we are making at 1 in case of branch 2, and branch 1 also 1, and branch 6 it is 1. Okay, and cut set 2. Okay, second cut set. In the second cut set, again what are the branches it is associated with it? 1, 3 and 5. Okay, all the directions are oriented towards, because everything is moving towards 4, whereas the direction of the cut set is also inward, right? So the direction of all these branches are similar to C2. That's why we are having branches B3, B5 and B1. It's having +1. Okay, and whereas the cut set C3, in this one, what are the branches available here? 4, 5 and 6. If you are considering the cut set direction is away from this particular node, okay, but the branches 6 is approaching that node, it is opposite to that of the cut set, right? So only that B6 will be -1. Okay, and similarly here also can be divided into two parts. That is the cut set matrix belonging to Twix, as well as the cut set matrix belonging to link. Okay, here since the cut set is associated with the Twix, the CT becomes unit matrix because the diagonal elements is 1 and off diagonal is 0. Okay. So since the cut set is associated with the Twix, the Twig cut set matrix becomes unity. Okay, unit matrix. So it is represented by letter U. Okay. So now we have seen three matrices A, B, C. A is the incident matrix, B is the tie set matrix, and C is the cut set matrix. Right. Now, there is a relationship between these matrices, and these relationship matrices, the relationship between these matrices can be given like this, like a matrix A into transpose of the matrix B. What is the P transpose? It is you are making the rows into columns and columns into rows. Then if you are multiplying, you will be getting as 0. Okay. Otherwise in the opposite way also, like a B matrix multiplied with the transpose of this A matrix, then you will be getting 0. Okay. This shows that there is an orthogonality between this A and B. Okay. And similarly, there is an orthogonality between C and B. Okay. And that's why it has become 0. Based on these two equations, we cannot say that A is equal to C. Okay, this is not like algebra. This is a matrix, right? Matrix, we cannot say that A is equal to C here. But what is C? It is nothing but the inverse of the incident Twig matrix of incident matrix. Okay, so Twig part of the, what is C? C is nothing but AT inverse into A. What is AT? It is the Twig, it is the incident matrix which is having only the Twig elements, right? Which is having only the Twig branches. Okay. So that if you are taking inverse and if you are multiplying with A, then you will be getting a matrix C. Okay. This is the relationship we can have between these A, B, C matrices. Okay. And similarly, like based on these equations, these can be expanded and we can derive in terms of like a BT. BT is nothing but the die-set matrix, which is having only the Twigs. Okay. Similarly, we can derive for CL and BL. Okay. So individually, it is determined like it is showing the relationship between among these matrices. Okay. So these are the self-assessment. So you have to identify the possible number of trees for the given circuit. For this circuit, you have to find possible number of trees, right? And you have to take one tree which should be other than this tree, right? How to write the incident matrix, die set as well as cut set matrices. Okay, and after deriving ABC, you have to verify this relationship. Okay, after finding ABC, you try with like a matrix A into transpose of B, you will be getting 0. You should get 0. Okay, so you can verify this relationship. These are the self-assessment for this lecture. Thank you.